Hello learners, very good morning. Welcome back to my YouTube channel. And we are learning Linux through this series, Linux the Final Boss series. This is the day one of new series. Let's talk about what we are going to discuss and let's get started. So today we are going to discuss about what is Linux. Why as a DevOps or engineer we should learn Linux. What are kernels, what are distributions, what are package managers, and some interesting topics. I have created all the notes here and exercises documented on my GitHub repository, Linux the Final Boss, which you can fork and make sure you give it a star as well. Let me tell you, I found one survey and I read that over 96% of top 1 million web servers and 100% of top 500 supercomputers are running on Linux. That's a huge number. As DevOps SRE engineers, you will create, manage, automate CI/CD pipelines, whatever that is. Jenkins, GitLab, GitHub Actions. You will write Docker files. You will use Docker and Kubernetes for containers, containerization and container orchestration. You'll write a lot of automation script using Bash to automate workflows, to automate day-to-day activities. You will work on major cloud platforms like AWS, GCP, Azure, Oracle, which runs on Linux instances. And then you will use Prometheus, Grafana, ELK stack for monitoring observability. So various different tasks and activities that DevOps or engineers are totally dependent on your Linux systems. Okay. And more than that, your employers always ask you to have Linux proficiency in these particular roles. So if you are following my job posting series, there also I break down the JDs for the DevOps SRE engineers. There's always one skill mentioned there: Linux, just scripting, bash scripting. So that is why we are learning Linux. It is very important um, topic for us as a DevOps SRE engineers. Now, what is Linux? So three terms. Linux is free, it is open source, and it is Unix-like operating system kernel, which was developed by Linux Torvalds in 1991. It forms the core of many latest operating systems. We call them as a Linux distribution. And nowadays, Linux is almost used in your servers, desktops, embedded systems, supercomputers, IoT devices, mobile devices, and everywhere. You can compare Linux kernel with your car engine. Okay, so just imagine a car. Car have the car engine, mirrors, seat, the body, wheels, um, yeah, and many different components to form a entire car. But a car engine is a core component. Without car engine, your car cannot run, and there is no other thing which can control your car functionality. That is Linux kernel for you in your operating system. If you are interested to learn about history of Linux, then you can check out this history as well. Let's skip that part and let's directly jump onto main core components of Linux. What makes a Linux entire thing? So Linux is structured in layers from hardware to user applications. So it have a hardware layer which consists of CPU, RAM, disk, network, peripherals. Then there is a Linux kernel which takes care of process management, memory management, file system management, network management. And we have dedicated chapters in this series on all these topics. Then we have system utilities like your commands, ls, grep, systemctl, etc. Then we have system libraries, glibc, libc, OpenSSL, etc. Then we have shell, bash, zsh. Then finally we have user applications, Vim, Docker, Apache, etc. Okay, so as we discussed in hardware layer, your physical components comes into picture: CPU, RAM, disk, network interfaces, and OS interacts with hardware via device drivers in the kernel. Okay, what is the kernel? Kernel is the core of Linux operating system or any operating system, which manages system resources directly. What are the functionalities of kernel? So it takes care of process management, memory management, device drivers management, file system management, and network management too. That is why we are saying kernel is a core component which takes care of major system activities in your system. And then this very important question: kernel space and user space. So kernel works in two different modes. It works in kernel space mode and user space mode. And this is one of the questions which I have also got asked in my Google and Apple interviews. Because you won't see these, get discussed in a lot of online tutorials, and maybe that is the reason because people don't want go into much details how system works, and um, interviewers always like to grill on such topics. So what is kernel space? The kernel space is the privileged mode where kernel operates with unrestricted access to your hardware and system resources, which allows direct control over your CPU, memory, IO devices, but it also isolate to prevent crashes from affecting the entire system. User spaces. So this is the mode. It's a restricted mode for user applications and utilities. So kernel works in a privileged mode, and your user application and utilities works in a restricted mode. So apps here cannot directly access hardware to maintain security and stability, preventing a buggy app from crashing the kernel or compromising the systems. Okay, so how it exactly works? So it works using a system calls. Very important questions. What are system calls? System calls is a bridge between your spaces, like user space and your kernel space. So user apps, whatever the user apps are there, or the utilities are there, so they request kernel services. Example, open to read a file, or for to create a process via system calls. This switches the CPU to kernel mode temporarily, execute the request, and return results. We are going to discuss one thing later here: how exactly command runs behind the scene in Linux, and this is again very important question. Shell has, it's a command line interface. It's a CLI, so command interpreter, which we use CMD. Um, yeah, it can be Bash or ZSH, and very essential for your DevOps scripting and automation. This is the part where I want to spend some time. Um, what happens exactly when you run a command? When you run ls command or ps command or man command, what exactly happens behind the scene? Let's talk about that. So when you type a command like ls, which list directory contents, and press enter, the shell from where you are typing that command, it orchestrates a multi-step process involving user space and kernel space. And here is a step-by-step breakdown. So as a user, we type ls in the terminal and press enter. The terminal captures this as the input. Then shell passing happens. So the shell bash reads the command, it passes it, and determines it's an external program. Then path resolution happens. This shell searches for $path environment variable for the executable and finds bin_ls path. Then process creation starts. The shell uses a system call fork to create a child process for ls. So now see this entire thing. Like when we type any command from terminal, it doesn't directly run that command in the um, the kernel mode. It uses those system calls to call all those intermediate processes as well. So shell uses a system call fork to create a child process for ls, and then kernel switches to kernel mode. So kernel is a component which uses kernel mode, which loads bin ls into a memory and then start execution in user space. Then actual command execution happens. So ls runs in user space, makes system call again to open a directory and then read entries to interact with file system via the kernel. Then finally you get formatted output, um, yeah, and that output gets returned on your um, standard output or terminal using a system call write. Once that is done, ls exits and child process also ends with a exit system call and shell regains control. So this is the entire process which we discussed. Just to revise, when we type a command ls, we press the enter button. It does the shell parsing, then it resolves the path. It calls couple of system calls for to create a child process. Then kernel gets loaded and execute ls via execcv. Then ls runs in user space, calls a couple of more system calls, open directory and read directory. And system calls for writing output to terminal. Then ls exits the system call and your child processor gets killed and then shell regains the control of your prompt. That was in detail. You can skip that part if you want, but I would say that this is very important topic, and um, for top companies, this is a question always gets asked: how exactly things happen behind the scene, and that's why I'm covering this topic. Okay, you can also learn about Linux versus Windows. So I have documented a couple of things. Um, let's go over a few points. Linux is open source while Windows is proprietary. Then um, Linux hierarchical system is consistent, ideal for scripting and automation in cloud. Whereas in Windows, you might have seen those drive letters like C drive, D drive. So that's a different file system Windows uses. In Linux, everything is case sensitive, and in Windows, it's not. Linux can be used by multiple users. Windows is for the single user focused. Package management, so we use apt or yum for Linux, and in Windows we use .exe or .msa. Cost, Linux is free, no licensing, and Windows is you need paid license to use Windows. Uh, yes, security point of view, so strong privileges and open scrutiny in Linux, and Windows always get a lot of vulnerabilities and you need to keep updating your Windows system. Stability, high uptime, yes, without crashes, prone to reboots in Windows. So that is all about this difference between your Linux and Windows. Let's talk about Linux distribution. This is one of the concepts which a lot of learners get confused. What are Linux distributions? They always confuses it with different topics. So Linux distribution is a complete operating system package which have your Linux kernel, GNU tools, package managers, and application. As we discuss about that car analogy. So let's take the same analogy. So you can compare Linux distributions with different car manufacturers. So different car manufacturers like Toyota, Ferrari uses a similar engine, the kernel, but built different vehicles for different purposes. Example, family cars versus race cars. Each is a different distribution. Same here, we are talking about different Linux distributions built for different things. What are popular Linux distributions by category? So there are beginner friendly, such as Ubuntu, Linux Mint, Fedora. Most of enterprises company uses RHEL or CentOS or Ubuntu servers. For security focus, many enterprises go with Kali Linux or Parrot security operating system. There are lightweight embedded Linux distributions as well, such as Alpine Linux, Raspberry Pi OS. Then there are a couple of advanced distributions as well, like Arch Linux and Gentoo. But for DevOps and SRE engineers, we can use Ubuntu servers or CentOS system, or we can use Linux, Alpine Linux, or we can use Rail as well. This is very common in enterprises for long-term support and compliance. Okay. Um, Perfect. So I want to talk about package management now. What are package managers in the Inter Linux ecosystem? So managers are a cornerstone for your Linux ecosystems, which help you to automating software handling across distributions. Package manager is a tool that automates your installation, updating, configuration, and removing software. So you might have used the package managers earlier as well. How does the package manager work? We have repositories which fetches software from official online repositories such as archive.ubuntu.com for Ubuntu. That it helps us to installing software. It downloads the package from the repository, resolve those dependencies, configures it automatically, and we have a couple of commands to update all packages or any packages on our system. Then it also helps us to clean up softwares and unused files without residue. How package managers fetch your software from repository? So this is again another important concept which we will need in future as well. So package managers checks this repository list, um, /etc/apt sources.list in Ubuntu, and downloads the packages or dependency and installs them. So you can check that out. You can just cat for this file and check what are the different package managers or the repositories set there. Why to run? Okay, then you can use different package managers for different um, distributions. Okay, so we have popular package managers in Linux. So for Ubuntu and Debian, you will use apt. For Fedora, Rail, and CentOS, you will use DNF and Yum. For Arch Linux, you can use Pacman. If you're using OpenSUSE, then you can use Zyper as well. Commands are almost same. Couple of options here and there. You will come across these commands like sudo apt get, sudo apt upgrade, sudo apt install, sudo apt remove, auto remove, apt search. So you want you to do some practice on these commands as well and check out how they work. Okay. Um, okay, so I think there is one important question here which I wanted to go. Why run apt update after installing Ubuntu? So fresh Ubuntu installs may have outdated packages as well. So you need to run apt install sudo and then sudo apt update to update packages list from the repos you have configured, and then just do a sudo apt upgrade -y to install latest versions of all those outdated packages. Perfect. So what you can do, you can create different instances on EC2 and try to run at least these basic commands, sudo apt update, which will update package all the packages, sudo apt upgrade -y, which will upgrade install packages. Then you can try to install sample package nginx using sudo apt install nginx. You can try to remove that package using sudo apt remove nginx. You can do a sudo apt auto remove to remove unused dependencies, and also search for a package using sudo apt search nginx. I'd also suggest that do this exercise either on Fedora or Rail and use DNF package manager to check, update, install, remove the packages using DNF. Um, yeah. So this is a hands-on exercise which you will need to follow. You can use AWS account or you can use virtual box virtual machine. Yeah, or you can use local terminal as well. Mac OS or Linux is fine and perform this exercise. So first part of this lab is launching two different Linux instances. One is on the rail based and other one is on Debian based. Okay, so you can use AWS Amazon Linux to AMI for one of the instance, launch it, try to access and perform the same exercise, and then launch another instance, Debian based instance where you can use Ubuntu server and perform the part two. So what you need to do is that you need to connect to Ubuntu and Rail instance and perform couple of activities here. So run basic commands pwd ls man ls. Try to run cat etc os release on both the instances and compare what is the result. And then run all these commands, the package manager command which we discuss, apt upgrade, update, install, remove, auto remove, search. Okay. Um, yeah. So follow this exercise and make sure you complete all the questions as part of that lab. And don't forget to make sure you are completing the entire checklist. I also try to add a couple of important interview questions based on this topic. You may get asked not directly but um, indirectly the question about Linux kernel, how it is different from Linux distribution. This is very confusing for many people. What is difference between kernel and distributions? That's what we discussed. And what is kernel space and user space? Why the separation is important in system security and stability? N- uh, Name any popular Linux distributions and typical use cases in cloud environment. How do you use package managers like apt and yumwork and all those commands for the installation and installation? And yeah, how do you check the kernel version of on a Linux system, or how do you check the distribution on the Linux system? All those kind of question you will get asked in your interviews. Resources you can um, follow this YouTube playlist. That is enough for you because I'm spending a lot of time to create this content and one-stop solution. This is a final boss series. You don't need to look for any other solutions. You can join Google group and most importantly, you need to join our Discord server. We have Linux the Final Boss channel there. If you have any questions, then you can ask directly there. Perfect. The last thing is share your learnings. Make sure you are learning in public and um, you're using this hashtag Linux, the final boss, and daily DevOps challenge. Tag me. My name is Sagar.Utekar, and I'll help you to uh, get better reach for your content as well. So that is all for today. Tomorrow we are going to talk about virtualization and different types of virtualization. Okay. I hope this video is helpful. Make sure you complete all the steps as part of this day 1 challenge and share your learnings. Okay, see you tomorrow. Thank you.